going to plot some coordinates on this grid, this one here. Always start from the origin, from the center. To get from here to here, you need to go 2 to the right, that's 2. And you need to go 1 up. So that was 2 along the corridor, 1 up the stairs, 2 along the x-axis, and 1 up the stairs, up the y-axis. So that one there is the x value, right there on the x-axis, sitting on the x-axis. That 2 is sitting on the x-axis. And that 1 is sitting on the y-axis. So that's your x value and that's your y value. Right, let's do another one. To get from here to here, you're going to go 2 to the right on the x-axis, 2 to the right, and then 1, 2, 3 up, 3 on the y-axis. So remember, that's your x value and that's your y value. And similarly, this one is 2 along the corridor, 5 up the stairs. That's your x value, that's your y value. What about this one here? To get from here to here, that's 2 along the corridor, and then 1, 2 down the stair, that's -2. That's your x value, that's your y value. Now, if I was to join them up, all those crosses, I've joined all these coordinates, it makes a straight line. Now you'll notice all of these coordinates have got something in common. X equals 2 here, x equals 2 there, x equals 2 there, x equals 2 there. Right, the y values are different, 5, 3, 1, -2, because they're all over the place along the y-axis. But the x values are the same, x equals 2, x equals 2, x equals 2, x equals 2. This line, this orange line here is called x equals 2. And notice, this orange line cuts the x-axis at 2, right there. This orange line, this vertical line, crosses the x-axis at 2. So this line is called x equals 2. So if I have another line, like this one for example, this vertical line has crossed the x-axis at -2, -2. So this one's called x equals -2. Right, one more, going vertically. Let's say I've got this one here. This vertical line crosses the x-axis at -3. So that's x equals -3. This line is called x equals -3. This time I'll plot some crosses going this way horizontally. This one for example. Right, this one, to get from here to here, that's 1 to the right, and then 1, 2, 3, 4 up. 1 to the right, 4 up, 1, 4. Remember, this is your x value, this is your y value. Let's do this one. From the origin, to get from here to here, that's 1, 2, 3, 4 to the right, and then 1, 2, 3, 4 up. 4, 4. That's your x value, that's your y value. Let's try another one. To get from origin to here, that's 1, 2, 3 to the left, that's -3 there. And then 1, 2, 3, 4 up, that's +4. That's your x value, that's your y value. Right, what I'll do now, I'm going to join them up. Now you notice all the x values are different, but the y values are the same. That's y equals 4, y equals 4, y equals 4. This line, this horizontal line, is called y equals 4. Right. This horizontal line crosses the y-axis at 4, positive 4, so it's y equals 4. So if I had another line, for example, let's say it goes through this one. This horizontal line crosses the y-axis at 2, positive 2. So that would be called y is equal to 2. And obviously if I had a line going this way, crossing at negative 3, that would be called y equals negative 3. You just need to remember that the horizontal ones, the horizontal lines, are y equals whatever number it crosses through on the y-axis. And the vertical lines are called x equals to whatever number they're crossing on the x-axis. I'm going to plot some extra coordinates. Right, that one there. Right, start from the origin. That's 1 to the right, and then 1 up. That's 1, 1. Remember, that's the x value, that's the y value. Let's try another one. From the origin, that's 2 along the corridor, 2 up the stairs. That's 2, 2. That's your x value, that's your y value, and so on so. That's 3, 3. 4, 4. Even this one here, that's 0, 0. That's your x value, that's your y value. And it carries on this way. You can keep on going this way. Right, from here to here, you go 1 to the left, that's negative 1. And you go 1 down, that's also negative 1. That's negative 2, negative 2. Remember, that's your x value, that's your y value, x value, y value. But what do you notice? X and y value for each coordinate, x and y value are the same. X and y value the same. Same, right? The x and y value are the same. Same means equal. So if that was a 1, that'd be 1. If that would be 3, that'd be 3. If that was 100, that'd be 100. But I'm not going to plot 100 along the corridor here because I'm going to go off the paper. So you could say x equals to y, or you can just as easily say y is equal to x. Same thing. These two are the same thing. Now if you join these up now, all these crosses, preferably using a ruler, that line itself is called the x equals y line, or y equals x. I'm going to show you crosses going the other way. So that's a diagonal line. That's at 45 degrees, okay? That is 45 degrees. Half of 90 there. The y-axis and the x-axis make 90 degrees. Half of 90 is 45. So that there is 45. Just in case you're wondering. Anyways, what I'm going to do is plot coordinates going through the other diagonal. This one here. Start from the origin, get from here to here. It's 1 to the left, and then 1 up. That's minus 1, 1. This one here, minus 2, 2. Minus 3, 3, and so on. I could join them up. Well, x and y value are almost the same, except one's negative and the other one's positive. So you could say, when x is negative, or rather you could say y is equal to negative x. Or the other way, you could say minus x is equal to y. As you can see here, these are negative numbers, there you go, negative x's, and these are positive y's, positive y's. This thing here is the same as this. The only difference is they've been swapped around. So if I got a y equals to minus x, if I swap them around, you get the same thing. Here, let me demonstrate. Y is equal to minus x, y is equal to minus x. If I swap them around, you get the same thing. Minus x is equal to y. Minus x is equal to y. That's what that line is. Right, just a while ago I told you that the x-axis and y-axis are 90 degrees to each other. The technical name for that is perpendicular. The x-axis is perpendicular to the y-axis. They are in right angles to each other. For example, this line here, this line here, they are 90 degrees to each other, right angles. This line is perpendicular to this. Perpendicular. It's just a fancy word for right angle when two lines meet at right angles. But if you've got two lines like that, these are parallel. So opposite word of perpendicular is parallel. If you look back at this, we looked at just a while ago, you had the x-axis, you had the y-axis, you can see in green. You can see all the vertical lines there. X equals 2, x equals minus 2, x equals minus 3. These are parallel to one another. Right, and here you got the y equals 4, y equals 2. The y, these ones here, the y equals 2, y equals 4, they're parallel to each other, alright? But this line and this line, they're perpendicular to each other because it makes a right angle. Alright, so for example, the y equals 2, you would say y equals to 2 is perpendicular to x equals 2.